All right, algebra folks, we are near the end of Module 7, and you know what that means? Test time. So, as usual, I'm going to take the practice test here, and I'm going to work through all the problems, explain how I'm solving each of those, and provide this recording here for you. So, you'll feel free to stop it, back it up, review things again. If you didn't understand something when I go through a problem, if there's an area that you totally got it, skip that problem, save yourself a little time. But this is a good chance for you to just review the entire unit and make sure you're ready for the test. So strap up, put on your glasses. Let's get ready to roll with this. Maybe that's just me that's putting on the glasses, but one of us needs to see what's happening, and hopefully both. All right. Let's start out here. Number one, the correct classification of 5x plus 3x to the fourth power minus 7x to the third power plus 10 by number of terms and by degree. Now, I don't know why it says that. It doesn't give number of terms in the choices. But if we looked at it, there is 1, 2, 3, 4 terms, because terms are divided by some kind of arithmetic function, right? So in this case, pluses and minuses divide the terms. So there are 4 terms, 1, 2, 3, 4. But this is just degrees. So the degree of a polynomial is determined by the highest term. So x to the fourth is the highest term. This is a first degree term, right? It's just 5x. That's x to the first degree. 3x to the fourth, so that's a fourth degree, 7x to the third degree, and this is a 0 degree because it's 10x to the 0 power, which we will talk about. So this is a fourth degree polynomial right there. Remember, if you're talking about terms, if this was 3x to the fourth y squared, that would make it a sixth degree, right? Because you got to add them together if they're in the same term. And they're in the same term. But this just has x, so this is a fourth degree. All right, 4 polynomials are shown below. Which of the above is a third degree polynomial? All right, remember, so what degree the binomial, what degree it is going to be determined by the highest term. Now, this is a fifth degree, this is a third degree, this is a fifth degree, and this is a third degree. So there's 2 fifth degree and 2 third degree. So what's the correct answer? Because it's looking for a third degree. Here's the key right here. Binomial. Bi. That's 2, right? We have a monomial. Mono is 1. Bi is 2. Tri is 3. Trinomial, tricycle, 3 wheels. Bicycle, 2 wheels. Binomial, we're looking for D, the one that only has 2 terms. 2 terms. This one has 3 terms. It's a trinomial. So, third degree binomial right there. Don't get tripped up by that. Okay, let's look at number 3. Choose the polynomial that's written in standard form. Okay, so these are all polynomials, meaning they have more than one term. Polynomial. Standard form. Standard form means that as you go from left to right, beginning to end reading the polynomial, that the degrees of the terms goes down, right? Goes down. So this one goes from third degree, well, fourth degree, because there's x to the first, y to the third. Then it has x to the fifth, y. That's a sixth degree. That went up. That went from fourth degree to sixth degree. So that is wrong. How about this one? This was a sixth degree, and then a third degree, and then a first degree. This one looks right. Let's check. 4 and 2, that's a sixth degree, followed by an eighth degree. So that can't be it. That can't be it. And this is a ninth degree, followed by a 12th degree. That can't be it. So since these go up, this is the only one that's in standard form. It's decreasing in degrees as it goes from left to right. All right, choose the correct sum. We're adding polynomials together. So to do that, you have to identify like terms. 3x to the third, 5x to the third. Those are both third-degree terms. Negative 5x, positive 7x. Those are both first-degree terms. And then the constants, negative 8 and plus 3. Okay, so the constants go together. So if we're adding those together, then we're looking at 3x to the third and 5x to the third. That's 8x to the third. So that's going to be this one or this one. Right off, we can rule off this because we're adding negative 5x, positive 7x. Negative 5 plus 7 is a positive 2. These both have positive 2. Negative 8 plus 3, that's going to be a negative 5. It's got to be this one because this is a positive. All right, let's move down. Simplify this. This is a subtraction. All right, got to pay attention to the term that is a subtraction. So again, let's identify like terms. They're trying to trick us up. This one's not in standard form. There's our third degree, and there's our third degree. Make sure you identify the same degree of terms. So here's our second degree terms. And then we finally have our constants at negative 3 and negative 8. So our third degree terms, negative 5x to the third minus 4x to the third. So that's negative 5 minus 4 more. That's going to be negative 9. That's a positive 9. And these are, so we already know it's got to be that one. We can check the others. 6x squared minus 2x squared should be 4x squared. And negative 5 minus negative 8. Minus a negative is a positive. So negative 5 plus 8. Oh, that should be plus 3. They got that wrong. Oh, I'm sorry. I was looking at the wrong one. Negative 3 minus 8. That was right. Negative 3 minus negative 8. So negative 3 plus 8 is 5. I was tripped up there. So that is the correct answer. It was the only one from the first term we could tell right off. It has to be that one. So, all right. Before I do number 6, I want to go over some rules. Basic rules. If we're multiplying a base, the same base with exponents, like 2 to the power of something, or x to the power of something, keep the base and add the exponents. Like if we had the base of x and it is to the second power and we're multiplying it times an x to the fourth power, keep the base is x, add the exponents, 2 plus 4. That would be the same as x to the sixth. So x squared times x to the fourth, we add them, 2 plus 4, x to the sixth, multiplying. If we're dividing with a base, so if we have x to the sixth divided by x to the third, we subtract the exponents. So it would be x to the 6 minus 3, x to the third. We would subtract them. Subtracting 6 minus 3. If this was a fifth, it'd be just x, right? 6 minus 5 is x to the first. Subtract them. Okay, how about if 0 is the exponent? Then it equals 1. So if it's x to the 0, it equals 1. If it's 111 to the power of 0, it equals 1. If it is negative 42 to the power of 0, it equals 1. If it is a cat standing on top of a dog to the power of 0, it equals 1. If it's Mr. Brock to the power of 0, it equals 1. Anything to the power of 0, anything equals 1. So if 0 is the exponent, it equals 1 every time. Doesn't matter if we had parentheses x, y, z to the power of 0. Doesn't matter what x times y times z equals. It's going to equal 1 because it's all in parentheses to the power of 0. All right. If you're raising an exponent to a power, so if we have x squared to the fifth power, we are going to keep the base and multiply the exponent. So that is the same as x to the 10th because we take 2 times 5. 2 times 5 equals 10. X to the 10th. So exponent raised to a power, x squared to the fifth power. And then finally, if the exponent is negative, we have x to the negative 2 power. Then we move it to the denominator. We say it's 1 over x and make it positive. X to the negative power is the same as 1 over x squared. X to the negative 7th is the same as 1 over x to the 7th. All right, we just move it to the denominator. We just have a 1 left because there was nothing else, and it becomes that. All right, that's the basic rules for exponents that were in the lessons. So if you didn't understand those, this is kind of a summary of the basic rules that we're going to use on the following pages. So let's look at those. All right, the following table shows the length and width of two rectangles. Rectangle A has this length, this width. B has this length, this width. Which expression is the result of the perimeter of rectangle B minus the perimeter of rectangle A? So we have to find the perimeter of B and then find the perimeter of A, and we have to subtract them. So the perimeter, if we have a rectangle, remember rectangle is four-sided, length and width, length, width, but the perimeter is all the way around. So we have another length and another width, right? So we have two widths, two lengths to find the perimeter around a rectangle. So for B, let's do A first. Doesn't matter. We got to get both of them. So A, so we would have 2x plus 4 plus x minus 1 plus another, we'll keep going around the rectangle, 2x plus 4 plus x minus 1. Two of each. Add all those together. Then we just combine the like terms. 2x, x, 2x, x. And then we have 4, negative 1, 4, negative 1. 2x plus x is 3x, plus another 2x is 5x, plus another x is 6x. 4 minus 1 is 3, plus 4 is 7, minus 1 is 6. So 6x plus 6 is the perimeter of rectangle A. Same thing with B. 3x plus 1 plus 2x minus 3 plus 3x plus 1 plus 2x minus 3. Remember, length plus a width plus a length plus a width to find the perimeter. All right, our x terms, 3x, 2x, 3x, 2x, 3 plus 2 plus 3 plus 2. We have 10x. Then we have 1 minus 3 is negative 2. Plus 1 is negative 1. Minus 3 more, minus 4. So, which is the result of subtracting A from B? So B is our first one, 10x minus 4. And from that, we're going to subtract 6x plus 6. Got to subtract that, subtract the whole thing, which means we have to distribute 10x minus 4. If this is like a negative 1, right? When you distribute negative 1, it'd be minus 6x minus 6. 10x minus 6x is 4x. Negative 4 minus 6 more, negative 10. That is the horizontal method. There was also a method to where if you want to subtract 10x minus 4, you could put it in like a box. And from that, you're subtracting 6x and 6, right? Subtracting that. So 10x minus 6x is 4x. And negative 4 minus 6, it'd be negative 10. So you can do it the vertical method. But either way, you should end up right there at 4x minus 10. So you can either do it horizontally, distribute, or you can just put them underneath the same terms, the x's under the x's, the constants under the constants, and check it that way. All right, choose the correct simplification of this expression. Woo! All right, so what we have here is, here's one term and here's another term. This goes back to our rule for multiplying exponents. So if we have an x squared times an x to the fourth, it's x to the sixth. So for this, we have to identify like terms. x squared, x to the fourth, x to the sixth. Oh, I'm sorry, y to the sixth and y to the fifth. These are both x's, both y's. Then we've got z's right there. And finally, the last thing we have is the constants. All right. So if we have the constants, 2 times 5, that's 10. X squared times x to the fourth. Remember, our rule says if we're multiplying the same base, they're both base x, we keep the base and we add them, 2 plus 4. So that would be x to the sixth. Y to the sixth times y to the fifth. Add them, 6 plus 5 is y to the 11th. Z to the fifth times z to the third, 5 and 3. So we look for, there it is, 10x to the 6th, y to the 11th, z to the 8th. Multiplying, keep the x's, add the exponents. Keep the y's, add the exponents. All right, how about this? Choose the correct simplification of the expression 2ab to the fifth to the third power. This is exponent to a power. You multiply the exponents. X squared to the fifth, we multiply 2 times 5. So, since there's multiple terms in here, 2ab fifth to the third, that's the same thing as 2 to the third, a to the third, and b to the fifth to the third. Everything inside the parentheses is being raised to the third power. The 2, the a, and the b to the fifth. So 2 to the third, that's 2 times 2 times 2, because it's the third power, so we'd have 3 2's. So that's 8. 2 times 2 is 4, times 2 is 8. A to the third power, and b to the fifth raised to the third power. Remember, we multiply b to the 15th. 5 times 3 is 15. So which one does that match? Up, this last one, a 8a to the third, b to the 15th. There's our answer. All right. Step by step. Don't overcomplicate it. Just break it out step by step. All right. Number 9. Choose the correct simplification of this expression. All right. We have a couple of things going on. We have this term being raised to a power, and then this term is being raised to a power, and then those two are being multiplied together. So the first thing we need to do before we multiply is we have to take care of the exponents, right? Which is taking care of the parentheses. Don't forget kind of our order of operations there. Order of operations, parentheses, and exponents, then multiply, divide, then add, subtract. So let's take care of the first term. To get rid of the parentheses, we got to do the exponent. So that would be 2 to this power. Right? If we break each term out, each one of those terms inside, each one of those individual things inside is being squared. So the 2 is being squared, the x to the 7th is being squared, and the y is being squared. And then all of that is going to be multiplied. All of that is going to be multiplied by y to the 5th to the third power. All right. So let's take care of this. 2 squared is 4. X to the 7th squared is x, 7 times 2, or power to a power, is 14. And then the y is squared. And then all of that's going to be multiplied by y to the 5th raised to the third power is y to the 15th. So now multiplying this term and this term, the constant over here is 1. 4 times 1. X, there is no x term. So the x stays as it is. It's just multiplied by 1. Y to the 2nd times y to the 15th. When we have an exponent times an exponent, we add them together. So we're looking for 4. There it is. 4x to the 14th, y to the 17th. All right. Now we have a term divided by a term. A quotient, a to the 7th, b to the 8th, a to the 4th, b to the 4th. So our rule, if we go back to our rule sheet, when you're dividing, you subtract the exponents. X to the 6th minus x to the 5th was just x to the 1st, or when that was a third, 6 minus 3. So we have to subtract. So a to the 7th is the same as a to the 7 and 4. So it's 7 minus 4. And then the b would be b to the 8 minus 4. So that's the same as a to the 3rd, b to the 4th. All right, take the a's, subtract it. Take the b's, subtract it. A to the 3rd, b to the 4th. There it is. Okay, moving on. Let's simplify this. Now we've got a squared divided by b to the 5th, all of that to the 3rd power. All of that to the 3rd power. So when you have a fraction like this, divided a fraction, and you're doing it to a power, that is the same as a to the 2nd to the 3rd power divided by b to the 5th to the 3rd power. When both of those are raised to the 3rd power, we can split out the fraction and say the top and the bottom are both to the 3rd power. So this would be a to the 2nd to the 3rd. Got to multiply. Remember, when we have a power to a power, a to the 6th, b to the 5th to the 3rd, b to the 15th. A to the 6th, b to the 15th. That one right there. A to the 6th, b to the 15th. All right. Because remember, to the 3rd power really just means we're taking a to the 2nd over b to the 5th times a to the 2nd over b to the 5th times a to the 2nd times b to the 5th. To the 3rd power means we're taking it times itself 3 times. A squared times a squared times a squared is a to the 6th, b to the 5th, b to the 5th, b to the 5th, b to the 15th. Because when you multiply them, you add those together when you multiply exponents, right? 5 plus 5 plus 5. All right, choose the correct simplification of this. AB divided by a to the negative 5th. Oh, negative 5th. We have a negative exponent. So when you have a negative exponent, like if we had x to the negative 2, to make that a positive, you move it on the bottom of the fraction. It'd be a over x squared. If we had 1 over x to the negative 2, we can move the x on top of the fraction and make that. If this was a 4 over x, then we'd still have a 4 on top of the fraction. So 4x squared. 4 divided by x to the negative 2 power is the same as 4 as x squared. So if it's on top of the fraction, which is just over 1, you move it in the bottom and it makes it positive. If it's in the bottom, you move it to the top and make it positive. So on this, since this is on the bottom, an a to the negative 5 power, we can move it above into the denominator, and we generally put a before b. Now it's to the positive. This is the same thing as this. These are the same. A to the negative 5th, and the denominator is same as a to the positive 5 when it's on the numerator, because that's all over 1. Now that we move this out of the bottom, all that's left down there is a 1. So this is this right here. Same thing as this. Okay, let's move on to number 13. All right, choose the correct simplification of negative 9, a to the 3rd, b to the 2nd, c to the 10th. All of that, see the big parentheses around all of that, raised to the power of 0. What did we say about anything raised to the power of 0? Equals 1. I don't care what all that stuff. When you multiply and when you put a number in for a, b, and c, and you do all that work, and you take a equals 5, b equals 3, c equals 10, and you do all of those and raise it to the power, multiply by negative 9, and do all of that work, and then take it to the 0 power, it's going to equal 1. Because anything to the 0 power equals 1. So don't do a lot of work. You know, we could say it's negative 9 to the 0 power times a the 3rd to the 0 power times b squared to the 0 power times c the 10th to to the 0 power. But since everything's to the 0 power, it's 1 times 1 times 1 times 1. It's all 1. All right. Just sharpen my pencil. We're going through a lot today. All right. Choose the correct simplification of this expression. Okay, we have a term outside and then parentheses. So we just have to distribute, which means we're multiplying this times all the terms inside. So negative 3x squared times 5x. Well, negative 3 times 5 is negative 15. What's x squared times x? Add the exponents. And x by itself is x to the first. So x squared times x is x to the third power. Negative 3 times negative 4 is a positive 12. X squared times x squared is x to the fourth. And then a negative 3 times a negative 6 is a positive 18. X squared doesn't have an x, so it's just multiplied by 1 because there's an x to the 0, which would be 1. So this is our term. Now over here, notice these are all in standard form. They go from the largest, the fourth, the third, the second degree in the exponents. So our largest one is 12x to the fourth. So we need one that starts with 12x. That's one of these two. So it can't be that, can't be that. Our second term is minus 15x to the third. Up this one. Of course not, and then plus the 18. So this is the second one right there. So, all right, let's do the last one here on this page. We have a binomial times a binomial, 2 terms each. So we've got to distribute both of those and distribute both of these. So let's take negative 2x times 4x. Negative 2 times 4 is negative 8. X times x is x squared. Now, negative 2x times the negative 6y, because remember, we distribute to both terms in the other. So negative 2 times negative 6 is plus 12. X and y, they can't be multiplied times each other. It becomes an x and y because there's no x term, so it's just x. X to the 0 really is what there. It's 1. And y times 1. We got 12xy. So now we have to distribute the 6y and the 4x. 6 times 4 is 24. XY, there's just one of each. There's nothing to multiply together. And then the last one is 6 times negative 6 is negative 36. Y times y is y squared. Not quite finished. Notice these are all trinomials, all three. We have 4 terms, but that's because we have 2 that we can combine. These are like terms, right? These are x and y, x and y. So we have negative 8x squared. We have a 12xy and a 24xy. So if we add those together, we've got a 36xy, and then we still have our 36y squared. So which one of this? It can't be the fat one because we have a negative 8x. Any one of those. Plus 36xy. That is right there. All right, that is our answer. Because this one's minus and that's a 12. All right, moving on. Correct simplification of this. Now we have a binomial multiplied by a trinomial. Okay, that means we're going to distribute this 3 times. And then the negative 6 is going to be distributed 3 times. So 2x times 3x squared. 2 times 3 is 6. X times x squared is x to the third. 2x times negative 3x. 2 times negative 3. Put the constants, and then the x times the x squared. Now we got 2x times negative 6. 2 times negative 6 is negative 12. And x times 1, negative 12x. So that's the 2x distributed times each of those. Now the negative 6. So negative 6 times 3x squared. We have the constants, minus 18, which is negative 6 times 3. And then we just have the x squared. Negative 6 times negative 3x. That negative 6 times negative 3 is positive 18. And we just have 1x. Then we have negative 6 times negative 6 is positive 36. All right. Now we look for like terms.
Well,
There's an x squared right
why
there.
we're
We're going to
here,
combine the
squared,
x squareds,
so
and we have an x term right there.
you're the only one
We
here,
have
so I
one
thought
x to the
you
third
were
and one
the
constant, so
person
those cannot be
in,
combined. So if we
let's
take the
do
6x
that.
to the third, then we have negative 6x squared and negative 18x
Right,
squared.
great
So
timing,
we put those
Kylie.
together. Now we have negative 24x squared.
I was just
We have a
telling
negative
Ethan, well, I can
12x
help you
and a
right now 'cause there's
positive
nobody else here,
18x.
but
So
then
negative
you
12
dropped
plus
in,
18
which it,
is plus 6x.
you
And then we have our
no.
plus
It was
36
just,
at the end.
yeah,
So
it was
these
just
all have
funny.
6x to the
We expected
third.
it to be here. I expected
Negative
a lot of
24x.
people
Okay,
to
it can't be
so,
this
so
one.
Ethan, why don't you go to the breakout room
Positive
and see if
6x.
we can
Those
help
are
you
all
with that,
positive
and
6x.
I can help.
Positive
Yes,
36 up. There's our answer right there. That's the only one that matched
I need to
what
do
we
laundry.
had all the way through. These others were close, not quite there. All right, choose the
Oh,
correct
go
product
away
of
somewhere.
6x plus 2
Yeah.
squared. Okay, that means this whole thing is being squared. So that means this is 6x plus 2 times
Oh, really?
itself one time. So we should rewrite that.
Oh.
So now it looks kind of like these problems where we just have to distribute, right? We'll distribute both of those. 6x times
Well,
6x is 36x squared. And then the 6x times 2 is 12x. And then 2 times 6x is 12x. And then 2 times 2 is 4.
But Miss G was on here first, so I
All right, so that is 36x squared plus 24x, because these are like terms, plus 4. There you go. Now, if you remember the shortcut on this, if this is what you call a perfect square, this will make a perfect square binomial because you're multiplying something by itself. So that means you can take the first term and multiply it by itself. 6 times 6 is 36. X times x is x squared.
Okay,
you can take the last term, 2, and multiply it by itself, plus 4. And then to find out what's in the middle, you multiply them together and double it. 6x times 2 is 12x. If we double that 12x, now we got 24x. See, we end up with the same thing. You're taking that middle one and doubling it. That's the shortcut when you're multiplying something by itself. First term, last term, middle term is multiplying and doubling. Okay, you can do it like this, or you can do it with the shortcut, whichever you are more comfortable and will not mess up, right? Don't use a shortcut, it's going to mess you up. I'm going to do this one with the shortcut since we talked about this way. I could write 3x minus 8 and 3x minus 8 and do that. But I'm going to do the shortcut. 3x times 3x is 9x squared. Negative 8 times negative 8 is plus 64. Okay, that's the first and last term. We just square those. Now the middle term is 3x times negative 8 is negative 24x. Right? And if we double that times 2, instead of negative 24, we have negative 48x. So minus 48x.
Good on you.
Right there. There we go. All right. Moving along. We're on number 19. How many more we got? Looks like 2 pages. That's it. We're almost to the end of this. Choose the correct product of 7x minus 3 times 7x plus 3. Okay, I'm going to work this out, but then I'm going to see if you notice something because there's a shortcut for this too. So if we distribute, all right, so 7x times 7x is 49x squared. 7x times 7x. And then when we take it over here, 7x times 3 is 21x. In the middle, distributing this one to both of them, negative 3 times 7x is negative 21x. And negative 3 times 3 is negative 9. So let's simplify. We have 2 x terms, right? We have this one and this one. Those are both just x's. So we have 49x squared. Positive 21x minus 21x. Hey, that's 0. Minus 9. So we're looking for this right here. So when you have 2 binomials multiplied by each other, and the only difference is the sign in the middle. One of them has a negative, one of them has a positive, but otherwise they're exact same. They both have 7x's, they both have 3's, right? In that case, you know that middle term is going to go away.
They just give us a number.
So we can take the 7x's and multiply them together. And we can
That's what
take
they're
the negative
trying,
3 and the
so-
positive 3, multiply those together,
Then
and
they
we know
give
there's
us a
no middle
number
term.
and a
That will be true
direction.
every time
That's
if you have a binomial the first time. If we had
Then they
2x
just
squared
give us
minus
a
8
number and no
times
direction. That's what we call a
2x
scalar.
squared plus 8, the only difference is the plus and the minus.
Okay?
The only
So the
difference, we can just take the
between
first
a
term.
vector
2
and a
times 2 is
scalar
4. X squared times x squared
is
is x to the fourth.
direction.
So we know it's 4x to the fourth. Negative 8 times positive 8 minus 64. We could go straight to that shortcut and know that there is no middle term because the middle term would cancel out. One's positive, one's negative. All right, little shortcut there to help on these problems right here. Let's find the quotient. Well, we got 21x squared y to the 6th plus 6xy to the third minus 30xy, all divided by 3xy. So this is the same thing as 21x squared y to the 6th divided by 3xy
Yeah. Okay. So
plus 6xy to the
let's
third
look at how
divided
we-
by 3xy minus 30xy divided by 3xy. When you have all of this divided by that, that's the same as taking each one of those terms individually and dividing it by the denominator. And this might be easier to look at. So
All right.
let's look at the constants first. 21 divided by 3 is 7. X squared divided by x. Remember when we have the rule when you're dividing with the same base, x, they're both x's, then we subtract 6 minus 3. So 2
All right,
minus
so
1, that means it's just
Then
x.
we have
Y to the
vectors
6th minus y. So this is a y to
We
the
have
first. That's an x to the first.
instead of scalars.
So that's going to leave y to the 5th. 6 minus
They
1
can cancel each other out.
plus
We can do
6 divided by
we can
3
do some
is 2.
canceling, we
X
can do
divided by
some
x. What is
adding
x divided by
from
x? It doesn't matter what x is.
positive
If it's
direction.
5 divided by
So,
5, it's
let's look
1.
at this
If it's
guy
11 divided by
here.
11, it's 1. If it's 9,000 divided by 9,000, it's 1. So the x goes away because it's just times 1, right? Multiplying times 1 is nothing, so we don't put that. Y to the third divided by y to the
Well, now you
first
know
is
why my
y
heart beats
squared.
right, 'cause look at that. All right,
And the
so
last
let's
term
say
is
this little
negative
guy
30, so minus 30 divided by 3.
walked
That's minus
5
10.
blocks
xy
east,
divided by xy, that's just going to be 1 times
and he
1
went east.
times 1.
So
So
do
it's just
we have
10
a vector or a
because the
scalar?
times 1 is not going to change anything. So 7x to the 5th, okay, it's
That's
one
a
of these
vector
three. It can't
because
be the
that's
first one.
directions. Good job. All
Plus
right, so
2y
then
squared.
he's at school.
They all have plus 2y squared.
Okay, and then after school,
Minus
back
10. Oh, this one doesn't have a square.
5
That's just 2y.
blocks, but now he's going
Minus
west.
10. Minus 10
Okay.
right there.
So
That one
if
right
we
there.
talk about what's his displacement,
Okay, got that? That times 1 didn't change anything. Negative 10 times 1 is just negative
which
10.
is like distance,
Okay, here's another one.
except
Just
it's
like the
different
last
because
one,
it
except we've
takes into
got
account
some
his
different numbers. We've got a
directions.
negative
So we
3x on the
talk about
bottom.
his
And we
displacement,
have some
his
different things. So
displacement
negative,
is
let's do this without breaking it out, but it's going to work exactly the same.
So he's moved
Negative
the
12
distance,
divided by negative 3 is
right?
a positive 4.
But in
X
displacement,
to the
he's
third
moved back to where he
divided by
started.
x,
So
that
we
means
say
subtract 3
he's
minus
not
1,
displaced at all,
x
even
squared.
though his distance is 10,
All right, let's move to the next term.
right?
Positive
So in
21 divided by
vectors,
negative 3. May be hard to see
if
that that
they're
is a positive.
opposite directions,
Positive
like
21
this
divided by
one's
negative 3 is
east
a
and
negative
west,
7.
he went
X
5
squared
blocks
divided
east,
by
and
x
then
is
he
just
went
x to the
5
first because
blocks
that's 2
west,
minus 1.
opposite directions.
And then
So we
negative 6
subtract
divided by
those
negative
because they're
3 is a
opposite
positive 2.
directions, and we
X
get
divided by x is 1. So 4x squared minus 7x plus
a
2.
vector of 0.
Oh, there it is. 4x squared
Okay?
minus 7x
So
plus 2.
now listen, there's
All
something
right,
else we
we're
need to
almost
do.
there. One page to go.
Let's say this
All right, so the
guy-
length of a rectangle is represented by this function. Length of x equals 5x.
this little
The
guy
width of that same
walked
rectangle is represented by the function
to school,
w of x equals 2x
and
squared
then
minus
after
4x
school,
plus
he went to his
13.
buddy's house.
Which of the following shows
So
the
he went
area
to his friend's
of the
house,
rectangle in terms of x?
which
Okay,
was
so the area of a triangle is, area equals length times width, right? We multiply to get area. So which one of these would represent that? It's not the plus. Okay, it's not either one of those. It's either
10 blocks.
length times width of x. So basically it's asking us if we multiply 5x
Okay.
times
And
2x squared minus
we
4x plus 13, what do we get? What do we get?
Which,
So 10x to the third, 5x times 2x squared. 5 times 2 is 10. X times x squared is x to the third. So those are the same. Here's where there's a big difference right away. Negative 4x or positive 20x squared. What is it? 5x times negative 4x. 5 times negative 4 is minus 20. X times x is x squared.
Okay.
And then 5x times 13 would be plus 65x. It is that one right there.
Because you did this
That
right
one
here.
right
You figured
there.
out that.
All right.
You figured out this
2
is
to go.
125.
If h of
just
x
forgot
equals
that
5x
it's
minus 3 and j of x equals negative 2x,
you
solve h of j
were on the
of
right
2.
path. So
H
what
of
we
j
did
of 2.
was take
So
the
since the
root
j of 2 is
of both of
inside the
these.
bracket, we have
So we
to
got
calculate what j of 2 equals. Okay, so let's find that too. J of x. If this was j of 2 instead of j of x, that means we would substitute 2 in for the x. See,
All right,
instead of
so
the
that's
x, now it's a
11.
2. Negative 2 times 2 equals negative 4. So j of 2 equals negative 4.
blocks.
So since j of 2 equals negative 4, that's the
that's
same thing as
one
saying what is
of
h
the
of negative 4?
Ways we can use
What is h of negative
So
4?
we can add
5.
them, we can subtract them.
H of
Or
negative
if,
4
like, they're
equals
right triangles
5
like
times,
this,
instead of
we
x,
can
we
use
put
the
negative
Pythagorean
4
theorem to find
minus 3.
displacement.
5
So
times
P
negative
is-
4. 5 times negative 4
his
is negative
displacement- his
20
displacement is 0
minus
because he
3.
ended up back at his house.
So negative
But-
20 minus 3 more is negative 23.
Yeah.
See, when we have
that is for displacement.
inside the
But
bracket,
distance
it's just like h of whatever that equals, and that equaled negative 4.
you gotta
So it's
figure out what
h
they're
of
asking,
negative
right?
4.
Distance
So we put negative 4 in the h equation and get
would
the
be
answer.
11.2
All right, here's a word problem.
blocks.
Not too bad, though. We can relate to this. Sarah's purchasing a shirt. It's on sale,
Okay,
20% off.
Let's do another
All right, found a sale. She knows the function that represents the sale price per shirt is the sale
started at his house again.
of P, whatever the price of the shirt is
He
0.8
had
times
3
P,
blocks to
right?
school.
Whatever the shirt costs, you multiply it times 0.8, and that is the price because 0.8 is 80%.
And then
Since
he went
20% off, you're going to
2
pay
blocks
80% of the
more
price. So
after
80%
school.
times the price. Where P is the original price of the shirt. She also knows she has to pay a 7% sales tax. Okay, we have to pay like 9.25% or
What
9.5%.
is
Ours is a
his
little higher than
displacement?
that. 7% sales tax. So the cost of the shirt with the tax is the cost of shirt is
Yeah, that's exactly right. So
1.07
these
times whatever you're paying
are
for
in
the
same
shirt,
direction. So
right?
they're
Which is right
all
here. The
equal.
S,
I should have put direction in here.
whatever the shirt costs, you got to
So they're
pay
all
1.07.
So if they're the same
0.07 is
direction,
7%.
then we
So
add
S
them.
is the sale price of the shirt. So we want to determine the composite function. That's what this was up here. It was a composite function that can be used to calculate the final price of her shirt. Whatever the price is, right? Whatever P is, it doesn't tell us what the shirt originally was priced. We're just trying to figure out what function will help us figure that out. So we know its cost equals S of P, the cost of S of P.
So if the
But
displacement
what is S of P? So if we take the S of P,
is in
and S of P is 0.8,
opposite directions, this is what we did
P
before.
0.8,
Opposite
and we put
directions,
that into the cost, because that's what
then
our
you
S would be,
subtract. So I'm just writing this all out so you can get it in your notes.
would be
I see you're taking notes.
1.07 times, instead of S, we'd have 0.8 P.
And
All right,
add
1.07
same
times
directions and
0.08 P.
And
So
then
that's
if
where we
we
have to take our
get-
calculator,
If we get directions,
and we will
that
take
we can't add or
1.07
subtract,
and multiply it by
then,
times
and then we use the Pythagorean theorem.
8.
Yeah.
Or you can put the 0.8 in if you want to put it that way. It'll work either way. And that is 0.856. So, is it SP or is it just P? 1.07 times the S, but we substituted in for the S the 0.08P. It's just P. S went away because we substituted for S. So the S is no longer in the equation. That is our answer. All right. Oh, that is it. All right. Hopefully that helped you. Take the practice test. If you haven't taken it yet, see if that helps as you go through that. If you did take it and missed some, go back and look at this video and see if you can figure out the correct answer to yours, because you may have had a different problem on your practice test than I had, just a similar problem. Don't forget, Monday, which would be the March 8th, we're going to be doing a live review in class, which means I will have different problems. We're not going to do the practice test again. We're going to have different problems we're going to go through, and I'm going to go through those rules again, just a little bit differently. I'm going to show you how those rules came to be, right? Instead of just telling you the rule, I'll show you why the rule works, and it helps you understand it better. So if you didn't get those rules, make sure you do it right. And I'll tell you, you can use notes on tests, right? So I thought, what would my notes look like if I was going to take this test? So let me show you what my notes would look like. I said, I'm going to make myself notes. So right there's a snapshot of the notes that I made for this test. I said, this is what I would do. I would put down just the basic stuff of what a monomial, binomial, trinomial, polynomials, what the degrees are, how does that work, classifications. So I put all that stuff up there about polynomials. And then down here, I put those rules. If I have a to the power of m times a to the power of n, that would be a to the, and I add the m and n together. You could use notes. Make some good notes. I typed mine. You could write yours on paper. Get yourself some good notes. So when you take the test, there's that composite function. First, I evaluate what g of x is, and then I substitute that into f. Right? So make yourself some good notes. Use those resources that are available to you. Be smart about it. All right, make this easy on you. Don't have to remember everything if you've got good notes like that. So, all right, test week, March 8th. Do that following Sunday. Don't miss the review Monday. It'll be good. You can bring your questions. If you watch this and don't understand something, bring that question. We'll do it live. We'll talk about it. We'll help you understand better. Otherwise, I'll see you then, and do work you can be proud of.